Hey everyone, hope we're all doing good. It's First Skin. Hey, thanks so much for dropping by again. I'm doing good. How about you? And yeah, I got another day, another another math. That doesn't make sense, but another day, some new math. It's good to hear. Okay, so yeah, there's this person who wants to make an so that I replied to this person on Saturday. They want to make an animation of an ellipse turning into a a circle turning into ellipse while keeping the um perimeter constant. That actually turned out to be very difficult to do. I want to solve a prized question. It's about one of the Millennium problems, because I can't do those. Um, and so I said, they're probably better off just. Why did that link not work? I tested it, and it works for me. Okay, I don't know what's up with that, but anyway, I just said that they're probably best off just manipulating the equation for an ellipse and getting it to look correct, but um, they have some better answers than I provided. So I'm glad that someone else posted. At least it seems like they send book if your answer is correct. That'd be interesting to check out. I prefer to do like homework help questions, but that sounds like something to be curious to at least like look at questions that are similar to that. Okay, ODE initial value problem. Second order. I forget what the term is. It wouldn't be. Is that ordinary? When I forget what you have when you have like function of t. Maybe that doesn't actually affect anything. But I mean, for this, wouldn't you just plug it in? Because you just have to prove that this is a solution to the differential equation. You would take the solution and just plug it into the differential equation. Oh, then it goes on, hence finite value to the initial value problem. Yes, for scan. Hey, here, Ben. If you are in my Discord, you can put in the math questions like a text channel. Oh, or if you're, I shouldn't have assumed that you're in it. If you need the link, it's right there. Um, this is one of those ones where you have to like use one solution to find the other solution, I think. Question mark. I love the differential equations, but I really need to like study them more. So when you have constants, you can basically just treat it like a polynomial. Okay, so yeah, um, that won't be applicable. Does this have something? Okay, I see. Actually, wait, I can do this to rotate it, and then I'll bring it up on stream. No worries, man. So how many integer solutions to this? Um, is this I guess, it's a little bit weird because we just need x and y's that are integers, but the actual like root 2000 I assume is irrational. I'm not particularly good at these types of questions, but you can think about it. 20 root 5. Okay. I wonder, do you get anything meaningful if you square each side? Yeah, sure. Please give me a hint. Geometrically, you can draw the line. Will it be a line? I assume this would be like an ellipse. Okay, you're saying not the line. Or maybe a circle or something. The function general, okay. But even then, that doesn't necessarily help you get integer solutions. So you have to get both x and y as an integer. I guess it can, but hey, Safifi, it's been a while. How have you been? Yeah, how many integer solutions are there? Um, oh, so that's the hint. Isn't it 20 root 5? That's good to hear, Safifi. Getting more and more excited about tomorrow since you write a math exam. Oh, as in you're like you're the one who's creating the exam? That's interesting. I don't know why I can just rewrite the problem. Oh, no worries for skin. You're not creating. Oh, okay. You're just like taking. Okay. um. Well, good luck with it. All right. Let's break out the blue pen. Yeah. I've been good. Just doing the stream. It's picking up a good bit again now that summer is over, which is always nice. All right. So root 2000 simplifies to 20 root 5. And so we need to find integers x and y. So, oh wait, I guess we want to. We need things that have a factor of 5, or we need I think we can construct an integer that works. I don't know if that'll help us get all of the possible answers, but it seems like if we were to find an x and y that are equal to each other, we would want each of them to be 10. We want each of them to equal 10 root 5 at the end, because 10 root 5 plus 10 root 5 is equal to 20 root 5. And we want to square this, because the square root is going to undo it, and that makes it an integer as well to get rid of the square root. So 100 times 25 is 2500. So in theory, one x and y pair is 2500, 2500. Wait, that can't be right, can it? This does not feel right. Oh no, it's 500. I can't do math. That's a square root. I felt wrong as I was writing that. I squared the 5. Even though I forgot about the square root. So I made it 100 times 25 instead of 100 times 5. Okay. So this is one possible solution. Because 2 root 500 is equal. We could pull a 4 out of there to get 2 root 500. Because 4 times 500 is 2000. Okay. And so I think this is going to involve looking at factors of 20, or I guess different ways you can add up to 20 maybe, and you stick a root 5 with each one. So if we had, say, if we had, say, like root 5 and we squared it, and we had 19 root 5 and we squared it, would this also give us what we want? I think it would. So we'd have 5. I don't know anyone who has 19 squared memorized, but it would be I guess 5, 1 plus 19 squared. I don't think that can't be right, can it? You mean square times 5? Okay, so yeah. So I think I was just getting to that conclusion too, where it can't just be any numbers that add up to 1 and 20. It has to be perfect. No, I guess not perfect squares because 10 works. I'm not sure what exactly the pattern is, but a square times 5. Root 5 times n plus p for x plus y. Okay. So yeah, I'm trying to get the pattern of this. We know x plus y have to add to n plus p root 5. Root x plus root y. Wasn't n plus p here 20? Alright, so I'm not sure where... I'll just wait for you to say more. Okay, yeah. Root x plus root y is 20 root 5. But it's not any n and p that add to 20. I don't think. But I don't think like 1 and 19 works with the way that I tried. 0 and 20 would work. 10 and 10 would work. Oh. Uh, okay, yeah. Oh, maybe it's when you multiply, well, well, maybe when you multiply the two coefficients of root 5 together, you have to get a perfect square. Maybe that's where this is going. So we look at integers. The last part I don't understand, but I think, but what do I think? I feel like there should be a pattern here, but like my inclination is just to plug in combinations like, 0 and 20, 1 and 19, 2 and 18, and like going into the equivalents on each other. So it wouldn't be that hard to actually just manually count them. I'm sure there's a way to solve for it though. Um, Actually, did I even check? Oh, like, what is 19 squared? $361, $362. Okay, yeah. Um, so we need to choose an. I'd love to find the formula to actually do this, like solving for it rather than just plugging in numbers. It makes sense to me that we need to choose um, integer x's and y's such that when they get square rooted, they have the root 5 and the other part adds 20. Right. Equal to x and y, they must be an integer. Question is solving with this. Okay. Let a to the 2.5 equal x, and b to the 2.5 equal y. A and b are integers. Or rather, they don't have to be integers themselves, but they have to result in integers. Actually, they won't be integers themselves, I don't think. Maybe. I don't know. So if we took it, I guess, from this step, or I guess, I don't know, I kind of want to do 20 root 5. Maybe this isn't a good idea. But do Amy themselves have to be integers? Their common divisor is 5. I, I don't see what's happening with this 2.5 power thing. Or I guess, why do we get 2.5? No, bro? Okay, then I'm completely lost with what you're saying. Oh, a square times 5. That makes a lot more sense. Okay. So let me write it like this then. 5a squared equals x. 5b squared equals y. Okay, so then we plug it into... Oh, I guess if you put the 5 in front, I like the way that I did there. I would have cut it, but it's all good, man. Um, so I guess if we plugged into this step, we would get root 5a squared plus root 5b squared equals 20 root 5. And so then we can pull out a root 5 as a common factor, and the squares can get square rooted. A plus b root 5 equals 20 root 5. A plus b equals 20. Okay? So is it any combination of a and b that add to 20? So, I mean, I thought I tried that with 1 and 19, though. Olympiad question from university. Oh, okay. But if I just tried it with the 1 in 19, I just want to see how this like works. Oh shoot, I zoomed this. Square root 5 times 19 squared, oops, plus square root 5 times 1 squared. Oh, you do get 20 root 5. I just did something wrong there then. Oh, duh. Of course you should get. Okay, yeah. So if I didn't make it an arithmetic mistake, I might be able to get there in my own way. Okay, and so that means there's going to be I get maybe 10 possible solution pairs: 0 and 20, 1 and 19, 2 and 18, 3 and 17, 4 and 16, 5 and 15, 6 and 14, 7 and 13, 8 and 12, 9 and 11, and 10 and 10. So that there's 11 integer solutions. Well, I guess you can switch x and y and you get 22? No, 21. Yeah, I think I just figured out as you type that. Because, yeah, you can always switch around the x and y. All right, well, that's an interesting problem. It feels very, it still feels a bit weird to me that you can use any combination that adds up to 20, but when I actually try it, it does make sense. So I just need to get over it. All right. They have to explain it. So you have to solve it. Oh, okay. Yeah, here, Ben. So that when I was listing off the pairs before with like 1 and 19 to 2 and 18, I got to 11 total pairs, and I realized, oh wait, you can switch them too though. This browser feels like it's way over the halfway mark, doesn't it? Like, it's not zoomed though. Oh wait, it might be zoomed. Zoomed a little bit. Make sure it's fully expanded. Okay, that feels better. It can be 0 to 20 numbers, and there's 21 selections, right? Right. Um, oh, this might be reduction. Okay, so I was just thinking about this person's differential equation again. Um, I guess we can use either of these. We plug this into the differential equation, we get a new equation that can be solved for v of t. Okay. Should make sure that no one replied to this. So I'm not spending all this time just for someone else to. Okay. So basically, you take your first solution, you assume your second solution is some other function times that first solution. I guess you plug it in. It's been a long time since I've done this. I'm kind of curious to see what it's going to look like, though. Um, and they're both functions of t, so you have to do the product rule with v and t. Are those only derivatives of v? Terms involving v drops out. Okay. Oh, and then because you only have two terms, you can use a change of variables. Okay, let's try this. I'm kind of curious to see how it's going to work. Let me go like here. Put that down in the corner. Okay. My markers are still kind of dying on me. I had them propped up for a good while before I started the stream too, but oh my god, why? Stand up. Thank you. Okay. The red one so far has kind of been the best one, but it's really annoying to erase. So our differential equation is y double prime minus 3 over t y prime minus 4 over t squared y equals 0. Y sub 1 of t is equal to t squared. That's our given first solution. And we are also given y of 1 equals 4, and y prime of 1 is negative 3. So I think this is an assume step next, right? Yeah. Assume y sub 2 of t has the form v of t times y sub 1 of t. Now we plug y sub 2 is a solution, so we can plug this part into the differential equation. Well, actually, we know what y sub 1 is, so let's actually do that now before I get too ahead of myself. T squared. So we can take this, we'll have to differentiate it twice, but we can plug it in. Let's actually do the differentiation before we plug in, now that I think about it. So y prime, or y sub 2 prime, is product rule on that. V prime, what the heck? Oh, let's just take off the parentheses t. So v prime times t squared plus 2tv, y sub 2 double prime. We have to do the derivative on this. Two product rules now. V double prime t squared plus 2tv prime plus 2tv prime plus 2v. I think we're good. We can combine the middle two terms. V double prime t squared plus 4tv prime. Funny how that looks like a polynomial. I'm really being sloppy with the t going before the v or not. When I actually go to plug it in up here, I'll put the t in front. So t squared v double prime plus 4tv prime plus 2v minus 3 over t, plugging in for y prime, v prime t squared plus 2tv minus 4 over t squared v, oh shoot. Okay, fine, it's fine, who cares? V, t, who cares what comes first? Not me. Okay, so now we should get something that only has two terms after all this algebra shakes out. So we have one v double prime term. We have 4tv prime. Oh, it's going to be okay. Well, let's not try to do too much mentally here. 3 over t times t squared is going to be 3tv prime minus 6v. Make sure I'm not making a mistake this early. I think that's okay. Then coming over here, minus 4 over t squared v, t squared. Oh, wait, never mind. I thought it was going to be, I thought there was a plus in between for some reason. T squared and t squared cancel, so we just get 4v equals 0. Okay. We still only have one v double prime term. For v primes, positive 4t minus 3t plus tv prime. I flipped a sign, didn't I? Because the v terms are supposed to cancel out, and that should be, this should either be a +4 or that should be a +6, shouldn't it? Or that should be -2. What did I do wrong? Copied it down right, didn't I? Oh, I did not. I certainly did not copy it down right. That's a plus. Plus and plus. Okay, I think that was the only consequence of missing that sign though. And that does make the v's cancel, so we just get these two terms equal 0. And then we make the change of variables. W equals v prime, so w prime equals v double prime. And that gives us t squared equals w prime plus w equals 0. That's a first order linear equation. Can you even separate it? You probably could, but we do need to. I kind of want to do an integrating factor though. We are going to have to divide by t squared, but that's okay. W prime plus 1 over t, w equals 0. I mean, really, we should just separate it. Never mind. I'm not going to do an integrating factor. That's dw over dt. You subtract this to the other side and divide through by w. 1 over w dw equals 1 over t dt, right? We need a negative sign. So if you integrate each, you would get ln w equals ln, so the value of minus 1 over t. You do e to the power of each side to get w equals, do we keep the minus sign or not? I think we drop it, wouldn't we? I think we do, but I do kind of look back at the example here, just make sure I haven't gone too off the beaten path yet. Um, I think this is right. I feel like we need this minus sign, man. I'm gonna put the minus sign there, and we can always check it at the end. So if w is equal to minus 1 over t plus c. Actually, technically we should have done a plus c out here, and when we do e to the power of each side, it's going to be, oh, never mind, the minus sign doesn't matter. So when we do e to the power of each side, it's going to be c over t. And c can be positive or negative, so it doesn't actually matter. Well, does it actually matter? We are solving for c. I'm going to put the minus sign there. I think it might not matter though. Dude, this is bad. Anyway, if w is equal to this, we know that v prime is equal to minus c over t. So if we integrate each side, we can get what v is. V is equal to minus c ln t. And we will come back up here and plug at minus c ln t in for t squared. Really? That's going to be a solution? Wait. No, it's not. How? Oh my god. Minus 1 over t does not integrate to ln of 1 over t. It integrates... The minus sign goes out front. What the hell am I doing? Oh my god. Okay. Just... No one look at me. I'm making all sorts of mistakes. At least I'm catching them. But god dang. Okay, so the minus sign is out front. When you do e to the power of each side, c e to the minus ln t. Wait, it will be... The minus sign would stay up there. C times 1 over t. So it is positive, but we still get c over t, funny enough. I'm just verifying this in my head. I think this is right, though. I'm not getting off the board anyway. Okay, good. So v is equal to the integral of c 1 over t. I'll actually just show this out instead of doing it in my head. C ln t. So it doesn't feel quite right, but we can always check it. I wonder if Wolfram Alpha can actually do this for us. Okay, let's actually try that. It's like, it looks like kind of a pain to derive and plug it back into the initial one. If we gave the differential equation and said what y equals, will Wolfram Alpha do the hard part for us? With y equals, I'll just set c equal to 1. Oh wait, no, with ln t times t squared. 4? Y equals that? Nope. I wish we didn't get a log here. It might make sense that we get a log, though. Might just be what we get. Just try bringing it home. Well, actually, I guess we can plug it in with the C and see what we get. So V is C ln t. That means a second solution to the equation is C ln t squared. If I really do want to verify this, so let's just go through the pain of plugging into the differential equation. Y sub 2 prime. Well, should we get C first? It shouldn't matter what C actually is. We can factor the C out. Deriving the ln as 1 over t times t squared is just t plus 2t ln t. Y sub 2 double prime is equal to c. T derives to 1. T derives to 1. Ln t derives to 1 over t times t is 1 plus 2. That actually is not too painful. So 1 and 2 add to 3, if you didn't know that. Plugging in up there, c times 3 plus 2 ln t minus 3 over t. C t plus 2t ln t plus 1. Shoot, I'm running out of space. Plus 4 over t squared c ln t squared. So hopefully everything should cancel when we get 0. We do get plus 3c minus 3c. 2c ln t let me just write this out. 2c ln t. The other term we took care of. The first term here we took care of. 1 over t, so 3 times 2 is 6. Minus 6. Minus 6c ln t. Minus 3 over t. Okay. Plus over t squared times t squared plus 4c ln t. This frickin' term. All the c ln t's cancel out, but we have that minus 3 over t. Where did that even, it comes from minus 3 over t c times 1, so I didn't write the c there. Wait, I thought that was a plus 1. I just inserted that plus 1 for fun. I was wondering where it came from. The absolute value of t looked like a plus 1 to me for some reason. I think it's right now, though. Okay. Yeah, I did just verify it. That was my biggest concern. Okay, so this is correct as a solution because it does fit in the initial equation. We do need to figure out what c is, though. And we can actually do that let's rewrite this. Y sub 2 of t is equal to c ln t times t squared. We know that y of 1 equals 4. Y sub 2 of 1 is equal to c ln 1 times 1 squared equals 4. That's not right. L1 of 1 is 0. We just get 0 equals 4. Well, that's not good. Like, why doesn't that work? Oh, wait. I think it's because the general solution is this. Or the general solution is a linear combination of y sub 1 plus y sub 2 with constants in front. Okay, never mind. We can't just take y sub 2 on its own. That's why I was using y sub 2 as if it was y, but it's not. Okay. That means y is equal to c sub 1 t squared plus c sub 2, which I'm going to transform this c into c sub 2 because it's all the same, ln t t squared. This needs to satisfy those conditions, not just that. Okay. So y of 1 equals 4 equals c sub 1 times 1. That one does become 0. So c sub 1 is just 4. Okay, that makes life a lot easier. I'll do plus 0 to show that I plug that in. Y prime, so we derive this to use the second initial condition, is 2c sub 1t plus c sub 2. Actually, we know c sub 1 is 4. 8t. Plus c sub 2, I'm factoring it out to do the product rule inside. 1 over t times t squared is t. 2t times ln t. Again, I'm being sloppy with ln versus t first, but who cares? Is equal to -3. Okay, now we solve this for c sub 2. Why didn't I plug in the actual number? Never mind. Actually, no, it's just the general derivative. Now let's do y prime of... God dang it. I am all over the place today. Okay, so we plug in 1, 8, plus c sub 2, 1. That becomes 0. Because ln of 1 is 0. So -3 equals 8 plus c sub 2. If you've gotten this far and you can't do this last step, then I don't know how you got this far. -11 equals c sub 2. Okay. Hopefully I'm still on the board here. Y equals 4 t squared minus 11 t squared ln absolute value of t. God dang, that is our answer. Take that to the bank, probably. Calculus looks very interesting to study again when you start university. Oh, cool. Calculus is probably my favorite thing in math. And I really like differential equations like this especially. I'm just very rusty on them, and I'm mostly rusty on math in general because I'm making mistake after mistake, but we got there eventually. If I was more confident in the math that I was doing, I wouldn't have had to go through all like the checking and stuff like that, but now next time a differential equation comes up, hopefully I'll have less trouble solving it. So for this person, what should we say? I want to link them to reduction of order. That's a good idea. Are you familiar with reduction of order? Link, question mark. These solutions, you can find a second one. Start by assuming y sub 2 of t is equal to v of t y sub 1 of t, not capital T. Oh wait, so actually I should look closer at their question. The part I'm trouble with is the initial value problem bit. Proving a normal with the initial value problems I'm familiar with, I have some concept of integration I'm trying to find. This is clearly not the case here. Okay, so I should actually back up a little bit. So how is your topology? Do you like calculus? I've never taken a topology class, and the little that I know of topology scares the crap out of me. And I would avoid a topology class like the plague personally. It probably is important, but that type of math just scares me. I'm not good at it. I like applied stuff. Addressing their question about how to approach an initial value problem. In this context, with differential equations, you need to first figure out what y is, which will involve constants or of integration. Then you can approach the problem normally with solving for c, or c sub 1 and c sub 2 in this case. Wish? You got it right, California. I just went to university in Hawaii. You got a question? What's up? Basically, start by assuming y sub 2 derive y sub 2 actually equals v of t squared y sub 2 twice and plug it into your differential equation. You will end up with an equation something v double prime plus something v prime equals 0. Then you take w equals v prime to get something w prime plus something w equals 0. And then it becomes a normal first order differential equation. Don does sushi. Both Don and Japanese steakhouses are known for their California rolls. Wait, what's my California roll? Because I'm rolling on the chair? uni roster? Class roll. Those people. I'm being stupid and I'm ruining your joke. I'm sorry. I know like what a roll call is, or like a list of people attending. I'm sorry that I'm being slow. I don't know if you were like lurking when I was working on this problem, but I made a million mistakes. It's a bad day to have a brain for me. Differential equation. Um, integrate W to get V. Plug into Y sub 2 equals E of T squared. Then you take Y equals C sub 1 times Y sub 1 of T plus C sub 2 Y sub 2. Also, why do Japanese steakhouse have California rolls? Like a Japanese restaurant would have California rolls, but not why steakhouse specifically? And then you're off by Peter's magnitude. Nope, I counted them. Hyperbolas and hyperboles. Not in my world. And that's your initial value problem. Okay. Hopefully this helps. I gave a very brief summary of reduction of order as a technique. And they just wanted a hint, and I addressed their more direct question of why the heck doesn't look like a normal initial value problem? Like it seems like they were asking. I'm saying basically twice here. Let me say instead, it's a brief summary. Japanese steakhouse around you also have a sushi bar. I don't think I've ever been to Japanese steakhouse actually, so I guess I wouldn't know. Let me make sure my link works. Okay, good. All right, that was a fun problem, even if I struggled with it a bit, but you know, it happens. I should make it more clear that this is V of t, because it looks like it's V times t squared. Oh, there probably is a Benihana around here. Teppanyaki, that sounds familiar, but I'm not sure exactly. I've never actually been inside one. I've been to like a local place that's similar where they make the food in front of you and they're like chopping the steak and stuff, or you know, that's how you chop if you didn't know. Oh, wait, I need to fix that one too. I haven't been to the actual chain one though. I don't think they had a sushi bar at the one that I went to. I guess I didn't see it if there was. They might have it might have been one of the deals where they had a normal bar where you can get like a drink while you wait for a table. Statics homework? Oh no. Yeah, this looks like a physics thing, but maybe it's not going to be that hard. They're looking for F3, the angle they've labeled alpha. They're looking for F3 in the angle they labeled alpha. Okay. So I'm balancing all forces to be 0. Okay. Oh. Oh. They have sine A plus cosine A equals that. If they did do it right, they could square each side and get, it's like sine squared plus cosine squared plus 2 sine theta cosine theta. I think, hey, Spetri. Hello, beautiful. Thank you. um, okay. I see something got posted there. Oh yeah, yeah, that was you. I'm gonna work on this one first in the browser because it's a question, or it's a more question someone has, but I'll look at that after. Yeah, I don't think it's probably should be that hurt, Spectre. You're right. I shouldn't be that scared. Um, should I check their setup too? I guess let's see. So they have a downward force, I guess a weight that's 900 pounds, and it has to. Things are the same, so all the down forces have to equal the up forces. So you have 427 F2, that's straight up, so you can take that as is. From F1, you get 445, the hypotenuse times the y component sine of alpha, plus F sub 3, which is 36 point. Oh, I guess they take that. Okay. You literally had this? Oh, okay. I definitely had to do problem like this in like a physics class. It's just been a while. But I think the setup is okay here. Because that angle is 36. They could have just done 3/4, but sine of that should equal that. Actually, let me plug in. Sine of 36.87. I just want to make sure that I'm not absolutely crazy. Oh, wait. That's radians. I want degrees. Wait, 0.6? Opposite? Oh, it's opposite over hypotenuse. Duh. Why am I doing... that was tangent. That's 3/4. Okay, let's just... Yeah, sine is right. It's going to be the y component. Let's not overthink this. Um... F sub 3, the total force... I mean, it should be 5. 3 squared plus 4 squared, and then you square root it. Well, what are they doing here? They turn sine into cosine. Oh, no, this is the... Never mind, this is the horizontal forces. I see. So they take 445 times cosine alpha and f sub 3 times cosine of the angle to balance the x components. From this one, they get f3 equals that. But if they know that's 3 and 4, I wonder if the 3 and 4 came later in the problem? Um, so, I mean, just from that stuff, they can figure out what alpha is. They shouldn't need to do both the x and y components, I don't think. But okay, down here on this line, they're taking the first line and plugging in. They put cosine twice. It should be sine. They plugged in this f sub 3 in here. I mean, this should technically work. Um, it's a lot of effort, though. Maybe I'm misunderstanding, but if the x component of f sub 3 is 3 and the y component is 4, shouldn't f sub 3 equal square root 3 squared plus 4 squared equal 5. Additionally, when you plug in your equation for f sub 3 into the first equation that balances the vertical direction, you flip the last sign into a cosine, and you shouldn't get that same cancellation. All right, maybe I'll say turn the last sign into a cosine. Because this cosine right here, it should be a sine. How they set things up, I think. So it would turn into a tangent and still be a similar problem. I think if you did have the situation sine A plus cosine A equals 473 over 445, you could square each side and use trig identities to simplify things. But finding f sub 3 equals 5 directly seems easier than trying to find, or directly then try to find alpha. Okay, 900 pounds of downward force and more than 900 pounds of up force. Did they have that? I don't see where they would have done that. Wouldn't alpha have to be really steep if there's only 4 pounds of force to the left here? Maybe this isn't the actual f sub 3. Maybe this is just the ratio, but it's not the actual. It's like if this was actually 4 pulling to the left, and you had 445 times something pulling to the right, you need to have a really small value times that 445. So okay, yeah, because I think that's an important realization, because it did, if I did misunderstand, because f sub 3 equals 5 seems much weaker than all the other forces. I think the situation they have is F2 is pulling 927 pounds. Oh, that's 427 Spectry. It does look a bit like a 9, but yeah. I think maybe here they're given the angle for f sub 3, and the 3 and the 4 are just things that they found like using the tangent. No, so they have to find what f sub 3 is and alpha. And so they get an equation for f sub 3 in terms of alpha from balancing the horizontal forces. They plug it into the equation balancing the vertical forces, but they made an error changing this sign into a cosine. So they should really get sine 36.87 over cosine 36.87, which is tangent of that, which is just a constant. And it should be 3 over 4 according to their triangle. Maybe it's not. No, it's not. No, it's using radians again. It is 3 over 4. Okay. Let me... They still need some guidance on what to do after this point. You didn't, or if the you didn't turn that sine into a cos, end up with 445 sine alpha, 445 sine alpha plus 440. Really get 445 twice? Oh, I guess so. Do we though? Yeah. No, that seems weird. I guess because F3 has to be balanced against. Oh yeah, it is 445 times a constant. 445 times tangent 36.87 times cosine alpha. Equals 473. 36.87 equals 3 over 4. So 445 times 3 over 4. I don't want to do that in my head. Lazy. 1335 over 4. How do you solve that though? Because now the constants with the sine and cosine are different, so squaring it isn't going to be as simple. Um, you could... No. I was thinking you could maybe divide through by sine or cosine. We could make it Wolfram Alpha's problem. We could definitely... That's one technique of solving this. I don't know if it's going to interpret alpha correctly. Oh, it does. I hate that. There must be something else that's wrong. I didn't really check their other work. Apparently it does, Maxi, even though it's ugly. Okay, I can't see what comes after that. Is there a different way entirely to solve this? Like if you tried, if you took it from this step and you solved it for alpha, just do Newton's method? I haven't heard of Newton's method for like a problem like this where you're balancing forces. It'd be like for differential equations, Newton's method. Or is that same like principle here? Finding the root of the equation? Oh, okay. That's probably more practical, but I feel like they shouldn't have to do that. So they're not really that specific on... Oh, I guess they are specific on what's given. Oh, it is the angle in F3. I didn't even see that. So they're given that the F1 is 445, F2 is 427, Um, the load is 900. F3 is dictated by a 3, 4, 5 triangle, so it's similar, but it's not exactly 3, 4, 5. So I need to rewrite the first part of what I put. But I think this diagram is basically everything. So F3 isn't 3 and 4 equals 5 for the hypotenuse. It's just similar to that triangle. I thought this problem would be simpler. it 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 shouldn't be that hard still. I'm just the algebra is a little bit finicky. The goal is to find F3, so the magnitude of it, and alpha. Oh, we know the angle of F3 and we know the magnitude of F1. I feel like we shouldn't have to do something fancy like Newton's method. We don't have to. The angle of F3, 36.87. Oh wait, shouldn't it be? It should be inverse tangent 3/4, which yeah, it's right. So it's 36.87 degrees, not radians. I can't talk. So I feel like their setup seems pretty good. Because this first equation is balancing vertical, so plus 427 plus 445 sine of alpha for the y component of f1 plus f3, whatever that is, times sine of 36.87 for f3's y component. Right, Max, it's in equilibria. We have to find alpha and we have to find the magnitude of f3. We only know f3's angle. And it's equal to 900, the downward force. So I agree with their setup for the vertical forces. For the horizontal, we only have f3 and f1 to worry about. Uh, 445 cosine alpha, which comes from f1 being 445. Then we have f3 times cosine of the angle of f3 equals 0. So this person solved the second equation for f3 in terms of alpha, and you get a stupid thing with sine of alpha plus cosine of alpha, and it's hard to simplify. What's the force up and the force to the right, not including f3? I think that's kind of the question. Um, things if we did do, let me make it like a little bigger but not huge. Okay, that's as good as I can get it. That's what she said. Um, well, the force to the right, the only force to the right is f sub 1, 445 times sine of alpha. So we end up with basically, we have two equations and two unknowns here, but it's not trivial to solve for them, I don't think. Um, yeah, we don't know the length of those up and right vectors because we don't know alpha. Alpha doesn't involve f3. Alpha is the angle of f1, and then we know the magnitude of f1, but not the angle. And then for f3, we know the angle, but not the magnitude. So they're kind of interlinked. Oh, okay, that makes a lot more sense. Right. We don't know its magnitude. I mean, I think that's why we have the vertical forces too. I mean, at least according to Wolfram, there should be just one or two solutions. I don't know if we're allowed to throw one of these out. Or probably one of them won't make sense. I I don't know about this one. Because trying to do the reverse and solving the second one for alpha, or the first one for sine of alpha, really does not make sense either. If we solve the first one for for f3, does that help or hurt or have the exact same problem? I think that's the exact same problem. If we really did just have this here, the problem wouldn't be that hard because you just square each side, but we don't. Hmm. I don't know what to tell this person. I'm stumped on that. Because I agree with their setup, it's just the math is not easy. I don't know. Briskin did post a question a little while ago. It's not really an actual homework question, but it might be interesting to look at it. Probably shouldn't spend too long on just one problem. I'll keep this one open in case we think of something, but it's been a while, so let me look at first scan, the one that they posted. E of x is a fourth degree polynomial with real coefficients. E of x is greater than or equal to x. Fourth degree polynomial with real coefficients. You're given a bunch of points that it passes through. Really? I've got to assume, I think you would need one more point to be able to solve explicitly for this polynomial. If you want to just ask me. All right, yeah, well, let me think about it for a little bit and then I'll see. Interestingly, like P1, 2, and 3 only vary by 1 or 2, and all the options for P of 4 are way higher. I think this is one where you need to use the answers. Let me just try the thing that I'm like my first instinct, even though it probably won't work. And then we can go from there. It's greater than or equal to x. Interpolate 5 points. Oh, so you would need 5? Even 4 isn't enough? Focus on that part, okay. Finding 3 coefficients of the poly. I think basically have 5 coefficients, don't we? We have ax squared plus, squared. Ax to the fourth, bx cubed plus cx squared plus dx plus e is greater than or equal to x. If it's greater than or equal to x, that means our quartic has to be something like that. E is greater than or equal to 0. True, yeah. If we try to draw it more exactly, I mean, it will actually touch the y equals x. Let's actually draw this a bit more precisely. Maybe this one that we can do graphically. Or at least get an idea for how to approach it graphically. You know, that's a good point, Spurskin. Okay. 1, 2, 3, 4. 1, 2, 3, 4. Wow, that is not the greatest spacing. So you're right. We do have this point in this point because p of 1 is 1, p of 3 is 3. P of 2 is 4. And it has to be above this line. And because it's a quartic, we have at most like 3 peaks and valleys. Does it have to be like that? Or like it's asymmetric? Maybe not exactly like that. It could be a little skewed, but I don't see how you make it symmetric. And it might be okay to have it asymmetric. Um, P of x minus x has roots there? Oh, I see. Oh, okay. So P of x equals that. P of x minus x is equal to ax to the fourth plus bx. I don't know if this part is even important to write out, but I will. D minus 1x plus e, and we know from this that it has to equal x minus 1 squared times x minus 3 squared. Because those can be the only roots. Could it be 3 and 1? I don't think so. Or 1 and 3, I guess. Oh, we would have a factor in front? Would it be A exactly though? I guess it would, because we could factor out the A. Yeah, I guess it would just have this general form. So then I guess we would use the P of 2. Like, I haven't looked at chat since Maxi said that, but look at P of 2 minus 2. Oops. A 2 minus 1 squared. Negative 1 squared is equal to 4. A times 1 times 1, A equals 4. Wait, why did I do... I did that wrong. P of 2 is 4. 4 minus 2 equals A times 1 times 1. A is 2. There we go. So the question was P of 4. So we have A now. So P of 4 minus 4 is equal to 2. 4 minus 1 is 3 squared. 4 minus 3 is 1 squared. P of 4 is equal to 9 times 2 is 18 plus 4 is 23. That wasn't an option, was it? No, I got right between 22 and 24. Wait, can I not do math? 18 plus 4 is 22. Newsflash. There we go. Thank you, Maxi. I figured it out right. As you said that. So yeah, okay, so the answer is B. Is that right, Swirskin? Oh no, I covered it up. Ugh, I'm sorry. Yeah, I guess I found A equals 2, and then plugging in 4 for everything, you get 22. Did we solve this? I haven't heard of that person. So what was that the right answer? The voice totally misses proof? Oh, it's a pretty fun one, although Maxley definitely helped a lot. So thank you for that, Maxley. It would have taken me a long time to get to that on my own. This was the original question. I don't know, I'll make it smaller, I guess. Get it out of the way. She makes videos about math, physics too. Oh, okay. It's taking forever to load because this browser is weird. Yeah. So yeah, and so basically you look at P of x minus x and you factor that, and you can get something that you can actually like plug numbers into. Hey Drew. All right, so let's. I still have no idea about this force one. It seems weird. Has anyone else responded to it? Oh. I'm gonna throw this out. Kind of all bad. Get that to be back to normal. Okay. Excuse me, I put the tab to the left. Okay. Um, let's look at this one. Close out of that. Find the equations of both the tangent lines to the ellipse x squared plus y squared equals 81 that pass the point 27,3. I guess you would have two tangent lines. Well, would you have two tangent lines? Smaller slope? I need to see what this looks like. Yeah. I mean, I'm not 100% confident in it, but I got to something that looks right, so. But there's like one step that felt like a little hand wavy. X squared plus 9y squared equals 81. And we're talking about the point 27, 3. Did I type that in right? The x's only go as far as 9. Oh, it's a completely... Oh! I get it. I was wondering how there could be multiple tangent lines. It's because we have a point way out here, and you can draw a tangent line, say, like from here over there, and then one down there. Okay, that makes sense of how we have two tangent lines. Okay. Thank you, Maxi. One of the slopes is 0. Oh, it's going to be level with the top? Oh, I guess so, because you divide by 81, and you get that the height of the ellipse is 3. You can also just see that the height is 3. Okay. And the point that we're given has 27, 3. I have dy by dx equals minus x over 9y, but I don't know what to do with that. I want to verify this. So I guess we would implicitly derive. Oh, I'm not sure exactly where this problem is going to go. Let's start by just verifying their dy by dx. I don't know how we're going to connect that to the point that's not on the ellipse. So there's no use in plugging the point in directly. We have to set it equal to each other? So we have x squared plus 9y squared equals 81. If you want dy by dx, that becomes 2x, implicitly differentiating. That becomes 18y dy by dx equals 0. Subtract 2x to the other side. Divide by 18y, we get minus 1 or minus x. Dude, can I do one problem without making a mistake today? 9y. So that I do agree with what they got. For dy by dx. Now, we need to find where on the ellipse our tangent line is going to hit. This is going to be weird. So so the equation for a tangent line, y equals, I guess that's our slope, times x plus b. Minus x squared over 9y plus b. This doesn't feel right. Can we plug in 27,3 into this, I wonder? No, it's not linear. I was just thinking that, like, if this is the slope of the line, could we plug it into here? I'm kind of curious what we get if we do plug in 27,3. Uh, 27 squared over 27 is 27. You get b equals 30. That can't be right. Yeah, I don't think that's a... Do we solve this for x or y maybe? Plug it into here. And then... I don't know. This is weird. I don't know how you... I can visualize what has to happen. Construct a function of the lower half of the ellipse and use that instead. Right. You rate the ellipse of the equation. We can, Jed. Just dividing through by 81. I don't know if that's helpful. So, I mean, if we did take just the lower half of the ellipse, we would rewrite that as y equals minus square root. 81 divided by 9 is 9. minus 1 over 9x squared. Lines y equals mx plus or minus square root a2 m2 b2. I can copy paste it. Oh, okay. I use that one. Yeah. What's the problem, Juha? Oh, it's x squared a squared. I was wondering why x2 a2. Okay, that was confusing me. Let's look at that one instead, because this site is kind of probably has the right answer. I'm just having trouble finding it on that page. All right, Juha. Why is that a tangent line? Because it's a point on the ellipse. Okay, that makes sense. It's what I got up there. Just with A's, I have A's and B's plugged in. But the y-intercept of the line is a point on the ellipse? No, it's just any y value. Never mind. When you plug in x equals 0, oh, you don't get... Maybe I'm overthinking that part. Gee, why is it m and not x? Maybe I don't get why. It probably does. I'm trying to figure out where this m comes from. Because it seems like it should be an x to me. Oh. Does this one explain it? So c squared equals the x turns into an a somehow. And the y turns into a b. I don't get where that comes from. But if we take it at face value, I still don't get. So the other page explains it a bit more, where it's a rearrangement of y equals mx. That they use c, but I guess c actually makes sense because b is already used. They rearranged this the equation for a line to be solved for the y-intercept. I think this, for some reason, square it, and the m here is the same as the m from the line. But I think they solved it for c and did something that I don't really understand. C equals y minus mx, and then I don't know. They really did. I could do a bit more explanation on both these pages. um, well, let me just try Googling and see what happens here. This is the exact same. Wait, this is a different academy, a different website. But it's like the same exact text. That's really weird. Or if y equals mx plus c and x squared plus, or x squared over, I think, does it? Maybe, Jed? We could do that, Maxi. I still don't know how we use that though. Hey, Shep. Yeah, this problem will probably make complete sense in French. Um, I think it must have something to do with if y equals, I'll say plus or minus 9 minus 1 over 9 x squared, and y, also, and the equation for the tangent line is mx, I'll say c. I think they're equating these two? Question mark? And then you get c equals minus mx plus or minus 9 minus 1 over 9x squared. Oh, about to give up? I see the joke you're making now. um, I don't want to do approximations though, if I can help it. I don't know why they square this. Um, I guess it gets rid of the plus or minus. I assume if you were to actually do that math and show it. Hey, hard lucked. 42, yeah. Let's look at Jed's link. I think I've explained why they get that equation. I don't necessarily know what we use it for. This is probably, stack exchange is probably a better place to look. Y minus 6 equals, oh, okay, so they're using that formula for a line. It's good to hear that you're good, hard lucked. I'm doing good. We've had some good math problems today, so that's the biggest thing I care about for these math streams. I also made a thumbnail for, actually it's not even going to be posted until tonight because it's going to take so long to render on YouTube. But I made a video of my first like 4.5 hours on a new DayZ map. And this morning I was playing around with GIMP. It's basically like a free version of Photoshop, making a thumbnail. And I kind of like what I came up with. It's basic, but making thumbnails is hard, so. Quadratic equation, ax squared plus bx plus c. Or it's really hard to I guess, think of an idea and like actually know like how to touch up photos, which I really don't. Um, they don't even derive it in this. Yeah, that's basically my plan. Just to learn it as I need to do things. Uh, third answer does derivation. I'm curious about this way. I was just surprised to see that it doesn't. Oh, wait, that's so simple. Stack Overflow, yeah, that's a good one. Okay, wait, I really like this third one. All the others are so complicated, but um, so if a line going through the point 27 comma 3 has the slope y minus 3 over x minus 27 rise over run. And this is also the slope of the tangent line, so we just set them equal to each other. Going back to bed? All right, sounds good, Shep. Let me get through this math problem. I hope you sleep well, Shep. Okay, so let's multiply through by the denominators. We'll get minus x squared minus 27x plus 27x. Uh, 9y squared minus 27y. That's not the easiest thing in the world to solve, but I think we're gonna have to use stuff up there. Okay, so maybe it's not as simple as I hoped, but I really like the setup and like what you have, or like the algebra will be a little bit hard, but the steps are much more clear with this method. So y squared, actually we know that 9y squared, let's do it one better. 9y squared is 81 minus x squared. Minus 27y, I guess we want plus or minus? No, I guess we take the minus one. I don't like this part. That's where things are going to get tricky. Let's see how it works out, though. Let's try and isolate this square root. So subtract 81 to the other side, add x squared to the other side. Oh, the x squared there goes away. 27x minus 81. We're actually going to divide by minus 27 as well in this step. 81 over 27 is 3 to the fourth over 3 to the third is 3? Okay, yeah. Did I just mark my forehead when I did that, by the way? I don't see a mark. Okay. 3, okay. Thank you, Jed. Is equal to minus root. I guess I could have flipped the minus sign back. I'm doing too many things at once. It's fine. It's all gonna get squared. All right. I guess we square each side now. 9 minus 6x plus x squared is equal to 9 minus 1 over 9 x squared. I don't think that minus sign is going to matter. I guess it shouldn't. So let's get everything onto one side. X squared plus 1/9 x squared is 10 over 9 x squared minus 6x. 9 minus 9 is 0 equals 0. X, oops, factor out an x. 10 over 9x minus 6 equals 0. X equals 0, comma 6 times 9 over 10. 6 times 9, 54 over 10. 54 over 10 simplifies to 27 over 5. Wait, I haven't gotten the sound alerts set up yet. I keep on meaning to do it, but it's so complicated to do it with channel redeems. No, I think the part was okay, Jed. Oh wait, did I actually flip a sign though? I said, oh man, I even said I was doing too much in my head. I feel like it shouldn't matter because we're squaring everything anyway. I need to redo this now. 27 minus 81, or 27x minus 81. We should divide through by positive 27. I guess you're right. But we square it anyway. So I gotta imagine this is gonna be... This is still the same thing. Because it gets squared. I did make an error in the sign, I think. Actually, no, I didn't. I divided by negative 27, and I kept the negative sign that was there. So I was doing it in an unclear way, but I think I did do it right. In either way, squaring kind of covers up any mistakes with that. I'm pretty sure it's right. I mean, we're going to plug it in to make sure. But so we already, Maxi already pointed out intuitively that we will have x equals 0 for one of these points just based off the setup of the problem. So that part gives me some reassurance. The 27 over 5, let's find out what the y value is. It's going to be obnoxious to do. 27 over 5 squared. It's 9y. Actually, I should use that equation. Well, no, I haven't used the initial equation. Equals 81. Wolfram Alpha is doing this for me. I'm not doing that. I'm just like, okay. I'll look at it in a minute. 27 over 5 squared plus 9y squared. What, like some kind of chump who actually does algebra? Wait. Plus or minus 12 over 5? It should be minus 12 over 5. Oh, yeah, because I did the general one. Okay. 0, 3. I know you can't see this. 27 over 5, comma, negative 12 over 5. What was the actual question again? Not that one. Find the equations of both the lines that pass through the point 27, 3. And so just before I close this down, we know that one of them, as Max said, is going to be a horizontal, or yeah, a horizontal line. So 27 over 3 is over here, or it's over here, and the top of the ellipse goes to the point 0, 3. That's why I wrote one of the points is 0, 3, the other point as 27 over 5, comma, negative 12 over 5. So hopefully this will make sense once we graph it. Actually, let me look at that Stack Overflow meme. I'm kind of curious since we are on the subject. So Bob, why should we hate? That's a stupid question. That feels very on brand for Stack Overflow. Oh wait, I'm not showing it. Dang. Freaking. There we go. That's a funny one. That's been my experience looking at Stack Overflow. Okay. Now we'll close down. So we know we have the point already up here just to make some spaghetti out of this. 27, 3, and we have it's one line passes through that point, one line passes through that point. We define both of their equations. The one with that point and that point is y equals 3, because it's just a flat line. But for 27, 3 and 27 over 5, annoying numbers, negative 12 over 5. I guess we could find the slope with that formula, couldn't we? Ugh. Yeah, let's just do it. X 27 over 5 over 9 times negative 12 over 5. The reason I'm doing this is because the 5s will cancel, otherwise I'd be too lazy to do the fractions. 27 over 9 times 12. 27 over 9 is 3 over 12. 1 over 4. Don't worry, I definitely didn't have to pause to think about 3 divided by 12. That means y equals 1 over 4x plus b, and we can plug in either of these points to find out what b is. Let's try that one because it's whole numbers. Well, I mean, even that one, who cares? 3 equals 1 over 4 times 27 plus b. Ugh, annoying numbers. 3 minus 27 over 4. 12 over 4, 12 minus 27 is negative 15 over 4. So y equals 1 over 4, x minus 15 over 4. Let's graph that and see if it makes sense. And we'll know if Jed was right with that thing that I did weird. Y equals 3. That makes sense. Y equals 1 over 4, x minus 15 over 4. At 15 over x. Bam! That point over there is 27 over 3. And I assume that's the decimal version. Okay. Problem turned out to be harder than I thought. The simplest way I found is to notice that the slope of any line that passes through 27, 3 is y minus 3 over x minus 27, i.e. rise over run, and that the slope of a tangent line, then the slope of the tangent line, minus x over 9y, we can then do this equals that, and use the fact that x squared plus 9y squared equals 81. To solve for where the x or y, where the tangent to the, or to solve for the point, to solve for the x or y where the tangent line passes through 27, 3. Maybe that's enough of a hint. They did post their attempt, so I wouldn't mind posting more, but I feel like it's going to give away the problem if I do any more. This first one, I have no idea about. I'm going to close out of it. Drew, are you still here? Do you want to talk about that probability one? I'm sorry, I'm just checking my Discord for what Shep said. If we're gonna probably, oh yeah, that is a pun. Let me share my Discord. So Jura gave a problem here. Suppose events A and B are independent, A and C are independent. Does this mean that A is independent to the union of B and C? It makes sense to me that it would be intuitively, but I was trying to prove it. And I did it kind of like a formulaic way. Yep, that's exactly what I did. So it was basically kind of like the reverse problem with showing that A is independent to the intersection of B intersects C. It's the reason you can't prove it. Oh, it's not true? Okay. Basically what I'm talking about is I went from this probability of A intersect B intersects C, probability of A times probability of B intersects C, and that would only be valid if A and B intersect C are independent. And it sounds like they're not. So that part, I didn't really know how to go either way, or how to like prove it or disprove it. So I just kind of let it be true, and it seems like it's not. So how do you prove? I assume that means that they're dependent then, and not independent like I thought. How do you prove it? And also, thanks Jed for the link on Stack Exchange for that Ellipse one. No one creating for a counterexample. Okay, I was trying to think of stuff like that, or like what if it is dependent, how, like what kind of example would disprove it? But I'm not sure, at least not right now. I was trying to do things like you know, a deck of cards and coins and stuff like that, but I couldn't really come up with a good. I couldn't engineer a good example that would fit the conditions. Okay. The outside dice roll is even as independent of the odds that it is in the set 1, 2, 3, 4, and this in the set 1, 2, or 2, 3, 4, 5. Oh, it's like the um, argument that I made involved doing with the intersection, but the problem that Jura initially asked was involving the union. And I think what you said would still be true for the union, or at least it would still work. Actually, I'm going to copy paste the question as Jura put it initially, just so people can read it. A equals heads, heads, tails, tails. B equals heads, tails, tails, tails. C equals tails, heads, tails, tails. So what does it mean when it's like A is, or I guess A is all the scenarios where you get heads, heads, and tails, tails. B is all scenarios where you have heads, tails, tails, tails. C is all scenarios where you have tails, heads, tails, tails. So the probability of A given B would you have to actually like plug in numbers and show that they so I assume if you were to actually like plug numbers in, you would find that P of A given B equals P of A and P of B given A equals P of B. I guess would you want to look at P of A given B union C and P of B union C given A? Because to me, it's not. It doesn't seem obvious to me because I'm not really good at this notation. So I think I would need to investigate it. I think it would be maxi. I'm just like not good with these, but it seems like it would be. But it'd be P of A intersect B intersect C, or union. B union C over P of B union C. So for the intersection, they only have TT in common. So the probability of TT is 1/2 times 1/2 is 1/4 over B union C is 1/4, 1/4, 1/4, and 1/4. 1/64. That doesn't make any sense. I don't know what's up with this. I'm gonna go conditional, just check if the requirements satisfy. I don't know what other requirement there is. There is for independence. Because heads, tails is 1/4. Oh, it'd be added, wouldn't it? And it should be equal to P of A, but P of A is not. Okay. P of A is 1/2, is a quarter plus a quarter. I guess that's enough to show that they're dependent. Oh, I guess you could have done that too. Or that probably is the much simpler way. The way that I was thinking was to show that, like, that is equal to P of A, or if these two are equal, then they are independent. Well, as long as you also do the flip. That way is probably a lot easier. P of A intersect B union C. It should be, well, we're going to show that's 1/4, just to look at it Drew's way. And it should be equal to P of A times P of B union C. P of A is 1/2. B union C is 3/4. So that's 3/8. So those aren't equal to each other. I guess there's another way of showing that. Okay. Well, I guess if you're willing to overlook my, I I don't. So I was trying to think of. I'm just not sophisticated enough with this kind of like notation to have thought of doing it this way. I guess I could have thought about it more intuitively, but that's why I was going for like the symbolic way of doing it with formulas, like I was trying to do, because I just really don't have a good grasp of how that stuff works. But it makes sense once I see it out like this. I think it's probably slot. Yeah, yeah. But it's probability, you know? You gotta. Okay. Well, it's only been 3 hours. See if there's any replies. I didn't realize it had been that long. We can look for another one or two though. If we can find one, I don't want to force it if there isn't one, but we'll give AskMath a good check because we only got partway through it. This notation is scaring me because it looks like analysis. Let Q R onto R, Q of X equal minus A times X minus 1 cubed, where A belongs to positive reals. I assume that's what R plus means. Actually, I don't think I've seen that before, but and what else does it mean besides positive reals? What are the possible number of solutions to Q of X equal inverse Q of X? It has to be one, right? I don't know how you would prove that, but I don't know how you have multiple inverses for a two-dimensional function. I guess I could see it for like three-dimensional. I don't feel confident about these. Oh, me being able to do these. Could you have multiple inverses? Maybe with a parabola? I'm trying to think of why you would ever have multiple. Wait, find the values of A such that Q equal inverse Q has three solutions? Oh wait, where it's equal to its own. I thought it was the number of inverse functions. I don't know why. Okay. How can a cubic be the inverse of itself? It must be symmetric about y equal x. I think that's possible. If you had maybe y equals x minus 1, x plus 1, and x. This is symmetric about y equals x. So I think this would be its own inverse. So I think it would. Really? Okay. Yeah, I don't know why it's different. It has multiple inverses. It's composite. I'll compose it with yourself and you'll get an x to the 9. I guess so. I guess this is x minus 1 cubed, though. And just by adjusting the value of a, I mean, or it's minus x minus 1 cubed. So just, in theory, just by just saying the value of a, get a function that has its own inverse? I have no idea how. Yeah. I guess you need a cube root. That's the inverse. Some kind of cube root. that makes sense when I actually think. Well, I mean, wouldn't it just be where they intersect? Not necessarily that they're equal, just that they intersect at. It intersects with its own inverse. So if you did take this, you flip it. Well, I mean, one of the later questions implies that it's 3. I don't see 3, though. I can see... Actually, I guess I can see 3. How often? Oh, yeah, yeah. I mean, I had a worse misinterpretation, so I can't hold that against you. Such that Q is tangential to Q inverse. I'm still not exactly sure how to do this, but I'm glad we at least understand what the first one is asking. It does seem like it would be 3, like, well, I mean, they always say in part E that, well, I guess it could be more than, you would have to show that it's not more than 3. The number of intersections with y equals x. Would it be that simple? But it's graphically, it only, I mean, but here it only has one, like, are you talking about like this blue function, the number of times it intersects y equals x? Like, no matter what our value is for a, it only ever intersects once. It's funny, it turns into like a straight line almost. So I think I like, or is there a different thing where you mean like intersections with y equals x? So this part E implies that it must be at least 3. I can't think it'd be more than 3, but I don't really know how you show that. I don't know. Hey, Anders. How's it going? I don't really feel confident enough to answer this one, but especially F is just completely different when it looks like. Not gonna say the family occurs. Oh, I guess it's related, but um, different. And the Ellipse function, you just swap all the x and y values when the inverse exists. Yeah, I mean, I could see setting those equal to each other, but I don't understand the thing like with intersections with y equals x. Just see if there's another one out there. I'll keep it open, but I feel like I'm too stupid. Yeah, Anders, the inverse. Q of x equals x, then. Oh, they would. Those points would have to be the same. I mean, that'd be evil if they mean 1 over qx. I don't think so, though. I'd hope they'd be specific about that. Okay, I hope, but how does part E say that there's 3 when if we graph it and try different values for A, there's only ever one intersection point? To have an inverse function basically needs to be monotone. That's some weird exotic example. Really? I'm trying to think of like for sine. I guess you do reduce the domain for an inverse sine. Um, okay, fine. Let's just you guys won. Well, let's just look at it. If q of x is minus a, x minus 1 cubed, for q inverse, x equals minus a, q inverse of x minus 1 cubed, and then you would solve this for q inverse. So you would cube root each side, divide by negative a. So q inverse of x is equal to cube root x over 3. Wait, why did I say 3? It's been the story of my life today. Plus 1. Okay. But like, okay, well, if we also do y equals, how do you do a cube root on the site? I'm just going to do the exponent. X over 1, I'm just going to say, to the 1/3 plus 1. Oh wait, I forgot a minus sign. Because the A has a minus sign. Whoa, that's okay. So there's 5 solutions in this example with A equals 1. I assume that's the most that you can have. I don't. The whole thing of finding the intersection with y equals x still doesn't make sense to me. Because it clearly only intersects once with y equals x, but we get, in this example, we have 5 different solutions. So that's where I'm confused on that part. If I also don't know how you solve, I guess you would have to equate these and solve for x, but I don't know how you do that. Unless I inversed it wrong. I could have. I don't think I did it wrong, but I did make an error, but solutions do have symmetry. That seems irrational. Okay, how about this? Since Drew asked if I inverse it wrong, let's plug it in. We're going to take a equals 1 just for the sake of the math. Minus, and then the x is going to be minus x to the 1/3 plus 1 minus 1 cubed. Okay, yeah, it is inverse correctly. You can compose function in Desmos. Oh, okay. I'm not very good with Desmos, so I wouldn't know. We do get y equals x, so this should be the correct inverse. So we can always get one solution where it intersects y equals x, but there can be multiple solutions. Or there can be, or not, that doesn't count for all the solutions. Like Maxi said, the other solutions do seem to be symmetric. So we get 1, 0, and 0, 1, 1.536 minus 1.54, and the reverse of that. I've got to think the other intersection points, I mean, like, the outer ones seem irrational, so it's going to be something weird. I don't really know. That kind of scares me, I guess. Because we could try equating the base function to its inverse and examining what values of a get you what, but that seems like it's going to be easier said than done. So that's why I want to move on from that problem. I'll still keep it open if someone has something more to say about it, but it's scary. Is there another name for this method? Oh yeah, sure, Anders. It is an interesting one. I think it's gonna be, it seems like it's gonna be really involved. Wait, what's the actual question? The chapter is called Transformations and Substitutions. We might be giving differential equations with linear coefficients. Is there another name for this method? Oh, isn't this exact? I mean, that seems like a different technique, though. You also can't generate a solution on the spot? Okay. Well, Anders, I don't have a way to prove it, but just when we graphed it, it makes sense if it's gonna be 5 at most 5. You could have less. I trying to go about proving it. My only idea is to try equating these two functions, except I plugged in one for a, but you'd have to keep the a there when you actually like do it on paper. So it seems like it's gonna be 5, but I don't know how to show that. Um, this isn't the way that I was taught to solve these. Let me see if I can see if Paul's online notes has a similar. Of degree 5? When do you get a polynomial of degree 9? Oh wait, that's not necessarily exact. I don't know what to help that person. I'll show it in the browser. So if you set these equal to, you're gonna have to cube root, or you're gonna have to cube each side, aren't you? So this one is gonna end up as to the power of 9. Because you need to get rid of this cube root on this term. Oh, I see what you're saying. We should get a polynomial of degree 5. But can you also have a polynomial of degree 9 with imaginary solutions? I don't know how that part works. But I'm seeing like algebraically, when you try to equate these two, you're going to have to cube it. We're going to try to intersect our function with the line y equals minus x plus b. Oh, if there's no way these are linear. No, I mean, you can. They don't even look linear. Oh, unless you don't mean the intersection points, just the function in general, maybe. I don't know. I don't know what to tell this person. I don't think I've seen equations of that exact form. No, it's not going to be Bernoulli. I don't know. Let's move on from that one too. Because I don't know what the name for that one would be besides what the book said. Um, Urgent homework question. It's had a good amount of traffic on the subreddit. Things this late have a good amount of comments though. We can look at this without using L'Hopital. Oh God. Why would you want to do it without L'Hopitals? Unless you get like a sin x over x situation where it's circular logic to use L'Hopitals, but oh, so you're taking advantage of the reflections, like this intersection point and that intersection point can both be put on the line y equals minus x plus b. Uh, that could simplify it. But like, this is a 1 point question. Like, it doesn't seem like it's the main point of the question. I feel like there should be some easier way, but that might be the technique to like rigorously prove it. So yeah, that you can definitely take pairs of these points as on the line y equals minus x plus b. Like, how would you do that if you don't already know one of the points? Or I know you're only like just working on it, but I guess that's my next question. Find the amount of beats for each intersection are reversed. We might answer the question. Yeah, especially they only give you 2 lines. I wonder if you're allowed to use a graphing calculator to actually look at it for yourself, or like how you're expected to do this. Maybe you can just draw it, as annoying as that would be. There's 2 possible values of A such that Q is tangential to Q inverse. I want to see what that looks like. Just at a 32/27, was it? Ah. What makes these tangential? Easy, so the answer is 5, 3, and 1. It's probable that the answers are 5, 3, and 1. If Q of X contains A, B, and B, A. Wait, I think that all that gets you is the point where it intersects Y equals X, though. That seems like another way of saying that. But wait, for this example, are these points even symmetric? 1.1850. Oh, these aren't even symmetric this time, I don't think. Oh, I see. Oh, I misinterpreted that, Maxi. I think you're right. But for this one, they aren't even symmetric, so maybe these symmetry arguments aren't going to work. 32/27. 32/27. So I was just curious looking at part D, where they say to use A equal 32/27, where they're tangential, but it doesn't seem tangential. And it also happens to be that the points of intersection aren't symmetric, so I don't know how that works. Or I really don't know how you're supposed to do it if you don't have that symmetry. Oh wait, I'm sorry. There's just only 3 points in this case. Never mind. Oh, let me see. That's the point of intersection there. Where do they intersect it? This must isn't giving me the other one. But you're right. No, I think they are symmetric. I don't know how they're tangential, but or maybe they don't. Do they only barely graze by it? No, that seems like an intersection point. Okay. Wish I could keep that point selected. Okay, there. Those are symmetric. Never mind. I was looking at this one because it just like filtered them for me. Uh, is that BA? Yeah. I think that still seems easier said than done. So this is the point A, and Q. I guess for that one, you could just plug in y for x or x for y and just get a true statement. Well, getting a true statement might be easier said than done, but this one, I don't know either. That's just such a weird problem. I don't know why you wouldn't want to use L'Hopital's. Let me erase what's on the board. I don't think it's that helpful. Hey, stay in the tray. All right, I don't do math for too much longer here. Can we do the limit? I can bring it up again. Uh, it looked really annoying to do without L'Hopital's. Well, it's specifically saying without L'Hopital's, and I guess that means you're looking for. I mean, I didn't actually try to plug in 0, but I assume you get indeterminate. 0 on top and 0 on the bottom, yeah. So, I mean, you could try using some trig identities or something, but that doesn't seem easy without L'Hopital's. General technique for the scalar everything. True, but I don't want to do that. I feel like I know if you have sine x over x, the Taylor series way actually isn't valid because it involves derivatives. For this one, I assume it is valid though, because this isn't sine x over x. Is the answer 0? I mean, we could plug it into Wolfram or Desmos or something. X cubed plus sine squared 4x over 14x squared. It is valid if you use Taylor series definition of sine. Okay. Yeah, I assume it's only a very specific case where you can't use Taylor series for sine x over x, but sine x tangent minus 6x. Come on. Whoa. It's minus infinity. That's a funky looking function. How does Wolfram Alpha do all alternate forms? It doesn't find any good simplifications, I don't think. All right. Two. Oh, it goes back up? They do it by series? Okay. I mean, I'm not going to do that on paper because that's going to be so much algebra. But I guess we can post for that person that they can use a Taylor series. I definitely don't see any algebraic manipulations that you can do to this to make it not 0/0, though. Unless you want to count Taylor series as an algebraic manipulation, I guess. Like, I don't see you being able to use any trig identities or any fancy cancellations. Yeah, I feel like they're... Oh, especially it's pre-calculus? There's no way they're in pre-calculus and they have this problem, and they know L'Hopitals. That flare can't be right. Um, and we can still just post it for fun, I guess. Like, I'm thinking like just posting this much is enough to technically answer their question. But I guess it is a day old and they don't have any answer at all right now, so I guess this is a way to avoid L'Hopitals.